Next, let's talk about the eighth signal. Okay, so eighth signal, which is x8 of t, which is nothing but u of t. Okay, so let us take x8 of t to be equal to u of t. So how does this signal look here? We already know that this fellow looks like this. Okay, it's an unit step function. So we want to find the Fourier transform of this signal. So clearly this signal is also not absolutely integrable. So, okay, so this signal is not absolutely integrable. So is not absolutely integrable. Okay, this signal is not absolutely integrable. So definitely what should we do? We should take the other method, okay, other route. So what is that? If you again remember the first chapter, so what is that we know that u of t can be written as what? 1 by 2 times 1 plus signum of t. So we can write our signal u of t as 1 by 2 times 1 plus signum of t. I'm not going to again deal with this because we have already seen this. Okay, so the unit step function can be written in terms of signum function as what? 1 by 2 times 1 plus signum of t. So because we know Fourier transform of 1, just now we have seen, and Fourier transform of signum of t. Now because of this relation, we can find the Fourier transform of u of t. Okay, so what does it mean? So Fourier transform of u of t would be equal to how much? Yes, so I'm sorry that I am using linearity property before mentioning that, but that's okay. So 1 by 2 is a constant, we can bring it out. We get Fourier transform of 1 plus Fourier transform of signum of t. Okay, so Fourier transform of 1 plus Fourier transform of signum of t. So this should be equal to how much? So just now we have seen that Fourier transform of 1 is how much? 2 pi times delta of omega plus Fourier transform of signum of t is how much? 2 by j omega. So what happens? You can send 2 inside and it will get cancelled. Finally, you will get pi delta of omega plus 1 by j omega. So that would be the Fourier transform of the signal u of t. Okay, so let us write down that. So u of t will have what as Fourier transform? Pi times delta of omega plus 1 by j omega. Okay, because it's a complex signal, it's not easy to plot. Okay, right. Next, let's move on to the ninth signal. Note that all whatever signals we are seeing, they are very important. Okay, so next let's move on to ninth one. Okay, and what is that? Let us take that signal to be a rectangular function which is defined as rect of 2 by 2t. Okay, yes, so we already know the plot of this signal. So it is a rectangular function from where to where? Minus t to plus t with amplitude 1. Okay, so you can easily see that this signal is absolutely integrable, and this signal has finite number of discontinuities, and this signal has finite number of maxima and minima, and hence this signal will satisfy our Dirichlet condition, and hence we can use the analysis equation directly. Okay, so no need to take the roundabout way. Okay, so what is x9 of j omega? That would be integral, actually should be from minus infinity to infinity, but for this signal it will be from minus t to plus t 1 into e power minus j omega t dt. Okay, so this should be equal to how much? E power minus j omega t divided by minus j omega, and integral limits will be from minus t to plus t. So this should be equal to how much here? So I will take minus 1 by j omega out. So if you take 1 by minus j omega out, you will get e power minus j omega capital T. You are substituting t with capital T minus e power plus j omega capital T. Okay. Yes. So you can easily see that this is equal to, what is this here? E power j omega t multiplied with, sorry, e power j omega t minus e power minus j omega t. So this you can simplify and show that this is 2 sine omega t divided by omega. Okay, so let us write down that. So what is the Fourier transform of a rectangular function? This is 2 sine omega t whole divided by omega. Okay, so let us try to plot this function here. So let us try to plot this. Okay. Okay. So what happens at 0 here? So clearly we can see that this is an even function, correct? If you replace omega with minus omega, you will get back the function. Okay, so just to make sure that everything is nice, what will I do? I multiply and divide with t. Okay, whatever Fourier transform we got, I multiply and divide with t, so that denominator also would be omega t and sine of omega t we will have. Okay, so what happens when omega equal to 0? This will be like sine 0 by 0 form, and hence that should be 1. So the sine omega t by omega would be 1 multiplied with 2t. So you will get 2t here. Next, and next what happens? This fellow will decrease and it will touch 0. So when will it touch 0 here? It will touch 0 when omega, so note that sine theta, when it is 0, it is 0 when the theta is equal to how much? Pi, 2 pi and so on. That is integer multiples of 2 pi. So I want pi here. So that should be, so what should happen to omega? Omega should be equal to pi by t. So at pi by t, what happens? That fellow will become 0 and this continues like this. Okay. So because denominator increases, so definitely the function goes down slowly. Okay. So I'll draw nicely. Okay, it goes like this. So what is this time? Definitely it should be integer multiple of 2 pi. You'll get 2 pi t, 2 pi by t. This will be 3 pi by t and so on. Okay, in the negative direction also you will get so this is 0. So this flow should be minus pi by t. This flow would be minus 2 pi by t, and this flow would be minus 3 pi by t and so on. And what is the amplitude at 0? 0 you will get 2t. Okay, so this is the Fourier transform of rectangular function. Okay, note that in time domain the signal is limited, correct? From where to where? Minus t to capital T. But in frequency domain the signal is unlimited. So we'll talk about this later. Okay, yes, but before we proceed to the next problem, let us write down this function in terms of sinc function. Okay, so that also we'll write down. Note, so what do we know? We know that sinc of x equal to how much? Sine pi x divided by pi x. Okay, so sinc x is equal to how much? Sine pi x divided by pi x. So now what did we get? We got 2 sine omega t divided by omega t, correct? So there is close relation between them, but not exactly, both are not same. So why? That pi term is missing. So let us write down that. Okay, sorry, this is 2t, right? So sorry, this should be 2t multiplied with this. Okay, because 2 sine omega t by omega can be written as 2t sine omega t by omega t. Okay, now what will we do? We'll start doing the gimmick. So what do I mean by that? You multiply and divide with pi. Okay, so you will get sine pi times, we want omega t, so you should divide it by pi, correct? Sine pi times omega t by pi. Denominator also we do the same thing. So because we want omega t, you will get omega t divided by pi. So this is nothing but 2t. How is this looking at? This is looking like sine pi x by pi x. So that should be equal to sinc of x. x should equal to omega t divided by pi. That would be the representation of the corresponding Fourier transform in terms of sinc function. Both are almost same except that that pi term is mixing, and hence we can represent our Fourier transform 2 sin omega t by omega in terms of sinc function in this form. Okay.